and I will share my screen. Share my screen, Chrome. Okay. Hope everyone can see my screen. Yes.
Yes, sir, we can see.
Okay, cool. You can only see the lecture notes, right? Nothing else, right?
Yes, sir.
Okay. So how do I put this in full screen? That was present about, right? Da, 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 da. Was it this 5? Completely forgot. Okay, this view slides. Sorry. Yes, the present amount, they have changed it. That's all. Format, slide, arrange tools. Oh, there you go, right, sure. Still, you guys can see my screen, right? Full screen?
Yes, sir.
Okay, cool. So, let me introduce a few things in the world of smartphone application development. Okay, so most of you guys must have an Android or iOS Apple phone or Android smartphone, right? So anyone have experienced these kind of phones, BlackBerry, J2ME, Palm OS or Symbian OS? Anyone have in here have seen these phones at least? Raise your hand, please. Anyone have seen? Okay, that's nice. At least a couple of people have. At least a couple of people are in my age, because these phones, Nokia, there was Nokia's Indian phones, and there were like what do you call then Nokia 16600. Those kind of phones are really old. When we are in schools, those phones were like the, at least we are having a camera and it was 2 megapixel and it's a big deal. Those phones were good at that time. They were capable of running MP3s. They were capable of sharing information via infrared or Bluetooth. So we were thriving at those days. But what happened was, there was a revolutionary product coming out of Apple. I would say that is the point of where the whole revolution of a smartphone began. It was with the iPhone. There were phones before that, but not as hyped as the iPhone, the first iPhone version. So what happened was, after introduction of the Apple iPhone, iOS and everything was coming into the market. Then later on, we had Android. We had Windows 10 mobile operating system. There was Harmony OS, and there is Google Fuchsia. Okay, perhaps you guys have not heard of some of these operating systems, since the dominant market is either it's going to be iOS based one or Android based one. So Windows 10 actually, it came and it gone. They are no longer providing Windows phones or operating system for out the public. And Fuchsia OS, perhaps if you are really into mobile phone, Google's new operating system that is competing with its own Android. Okay, but it's still not out there, but it's under development. You guys can check this out, but I'm not saying that okay, they will drop Android tomorrow and start using Fuchsia, but it is something that Google is trying to reach with something similar to iOS from Apple. Okay, I'm not 100% sure on their strategy or whatsoever. It's going to be an open source operating system, but mostly on Google's terms and conditions. Okay. All right. So let's talk about let's talk about the two giants in the smartphone industry. First one is being Android. So it's open source. If you know open source software movements, you can get the Android source code, the original source code for the Android operating system, applications, and everything out of there. I'm not saying each and every Android application is open source. At least the core Android operating system is open source. You can check it out. If you can compile it yourself, and if you are really good enough, you can even install it in your Android phone. But it won't be an easy journey, but you can do that. Based on the Linux kernel. Linux kernel is also an open source software, which is powering most of the servers, Ubuntu machines, and Red Hat Linux machines. So it is also powering Android mobile phones. So under that, if you are using Android, you are using Linux within your phone. So the main company behind Android is Open Headset Alliance. It's not a one single company. So originally, Android was acquired by Google, and Google made it open sources. Then there are a lot of interested parties coming in, especially companies like Samsung, Sony, and there is Huawei. Anyone who is running Android phone. So they came up and form an alliance called Open Headset Alliance, which governs Android right now. So they decide what to go into Android operating system, what's new features going to be there. But a lot of the Android source code is actually maintained by Google itself. So a lot of features they are entering. That's kind of a bias with the Google, and Google contribute most to the Android operating system. Then there is Microsoft also in here now, because they have found a lot of value in Android phones. So Microsoft is also joining the Open Headset Alliances, and they are giving the source code help and development of Android. Commercially sponsored by Google. So most of the time Google is behind these things. So this is a little bit of old slides. The latest version of Android is not 12. And the API level is not 32, but we will get into the latest version, and we will see when we are developing the application. So there are two things that you need to remember. There is the version, and there is the API level. We'll get into more on that, but just remember there is two things in order to remember. So main programming language, if you are into developing Android applications, first thing you will be learning is a programming language like Kotlin or Java. But as of now, as of 2017, as I can remember, Kotlin is the official language for Android. So if you are trying to develop a new application, it's going to be Kotlin by default. But if you have a very old application that you have to maintain, or you have to merge, you have to fix bugs and everything, it will probably in Java, but most of the time people are converting Java-based Android application into Kotlin. So everything new and fresh will be in Kotlin. So Kotlin is really easy and really fun language to learn. We'll see why. Okay, now for the iOS. So iOS is proprietary software. That means you can't see the source code anywhere. So Apple itself, they own the iOS operating system, and it powers your iPhones. And this is not confirmed data, but it's based on BSD or Darwin-based kernels, like Linux. You'll see in Linux as an Android, within Android, you'll see Darwin-based BSD kernel in iOS. Okay, so its whole property of its iOS is totally governed by Apple Incorporation USA. So you can't just take the operating system and do any modification on it. That is not allowed. So some components of the iOS operating system are open source. It's not 100% closed source. Some features and some things are there in Apple. They are open sourced, but not the OS as itself. So latest stable release is not iOS 15, it is iOS 16 as of now, recently released. So this should be updated. So we have iOS 16 right now as of today. And the main languages that you need to learn is either Swift or Objective-C. So earlier on, when you are developing old applications, when you are starting Android iOS application, you had to learn Objective-C. Objective-C is a little bit of troublesome language if you are new to programming. But don't worry, we have Swift, which is a great language. Compared to Objective-C, it's really easy to learn and really fun. And from my experience, Swift and Kotlin, they have most of the time similar characteristics, but I'm not saying 100% they are the equals, and they have different way of expressing few things, but most of the time you will see those are similar kind of language. But if you take Objective-C and Java, those are like two different languages. They have very less common way of syntax, a common way of structuring code, and so on and so forth. But if you take Swift and Kotlin, they are like really close to each other. So you'll be if you are learning Kotlin or Swift, you don't have to have a huge knowledge transfer or need to learn something from scratch. But since we do not have an Android iOS application development suite, we are not gonna focus on iOS side as of this moment, but we will be focusing on Android. That's because everyone can learn it, code it, and run it in anywhere within your machine. Okay, so iOS, if you want to develop an iOS, you have to have an Apple machine, at least a Macintosh or Apple, what do you call those things, AR or Apple Pro, what do you call these things? I can't remember. At least Apple hardware, let's say. You need Apple hardware to run Apple. If you need to develop an iOS application, you need Apple machine. So to run these things, these are mobile devices, right? Android, to run and develop Android application, there are a few ways. So first thing is that there are simulators within your machine. When you are installed Android Developer Studio, you can use the Android Developer Studio provide a simulator. Android, we have an emulator. Okay, don't get confused. Android, we have something called emulator, and using the emulator, you can develop your Android application and run it and see whether it's work perfectly. For iOS, you have the same setup, but in iOS we call it simulator. Okay, so there is a difference between emulator and simulator. We'll discuss further on. From iOS, you can develop your application and run it in a simulator and check whether it is working. Okay. The other option is if you have a physical Android device, okay, a physical Android device where you used to take the calls and everything, you can plug it in to your machine via a USB, or there is now option of over the wireless Wi-Fi configuration. If you have configured it correctly, you can run the Android application within your physical device. Okay, that is also now possible. Same goes for iOS. iOS did not allow that at first, later on they have decided to give developer permission for your phone. All you have to do is by default, neither of these phones installed. They don't allow you to install application even though you have developed it. You have to unlock the developer options. That means you specifically say your phone is allowed to run applications which is installed from your machine. Okay, so you need to enable developer mode on either of these platforms so you can run these developed application within your local machine. Okay, so either you go with emulator from Android or simulator from iOS, or you can use the physical device and check it out. So most of the time, like when you're developing an application, the simulator or emulator is enough. You don't need to physically own a device. What you can do is you can test your 90% of your application in emulator or simulator, but it's not going to be enough. Sometimes there are things that you can only do with physical device. Some things are there, they are not supported on simulation, and sometimes it's very hard to test on simulators or emulators. It will be much nice experience. It will be more practical if you guys can develop in the physical device. So in that case, you will be installing the application into a physical device, then you can test it out. Because most of the time you don't need to do, you can simulate and work on it. Okay, any questions up until this, guys? Okay, yes, anyone raise your hand? No. So one question is, can't we use devices to preview to run iOS apps in Windows? Unfortunately, no. Not sure whether there are hacky ways that you can do, but officially, what you need to develop or run an iOS application, all you have to do is run these in a physical Macintosh. Okay, otherwise it's really hard. I have seen some hacky ways doing these things, but I don't recommend those things unless it is really necessary, because the problem is it is not the perfect experience first, and the second thing is it will give you a lot of troubles if you're trying to go in a hacky way. Even I tried. There were virtual machines that you can try. There are VMs which pre-install iOS, and you can install Xcode and you can do the simulation, but that is really hard for your machine. Your machine should be either really powerful. If you are making your machine that powerful, it's cheaper to buy one of low-end Apple products. Okay, so from my understanding, you can't run any iOS application within Windows or Linux. That is not possible at this time. Yeah, so in device preview library, we can both iOS and Android. Yes. We will come into cross-application development in a moment. There are some exceptions, but it is not the same experience that you will see. We'll come to this in hybrid application. That's, I think it's my next. Okay, there are one more thing. So in Android, we have Google Play Store, Galaxy apps. These are the places where you can download the Android application, at least verified ones. Okay, so if you want to develop Android application, first thing is you need Android Studio. Or if you are really good at doing something like VS Code, that is also possible. But there are some options out there, but I highly recommend if you go with Android Studio. That is like everyone is using Android Studio to develop Android applications, so it makes easy, and this is having a lot of power to it. VS Code, of course, you can, but not that good. So compared to Android, and Android have somewhat light restriction in terms of installing applications, and security wise it is secure. I'm not saying it is not secure, but easy restrictions that you can, as a developer, if you know what you are doing, you can get rid of those restrictions within the Android phone. But sometimes that will void your warranty. But if you are up to it, you can do those things with Android. So in order to develop Android application, you will either need a Linux, Mac OS, or a Windows. So if you own a Mac OS based machine like Apple Air or MacBook Pro, then you are in luck. You can develop Android and iOS applications. But if you are stuck with Linux or Windows, unfortunately you can only develop Android applications. Okay. So for iOS, the main place that you can get the applications to install in your phone is the App Store. So this is the only place right now. A lot of people are like going against this idea. Okay, this is a monopoly. Apple is constraining. There should be other options, like in Android, you have Google Play Store, you have Galaxy app, and other providers have their own app stores. But in iOS, you only right now we have App Store only. There's no other places that you can get. So if you want to install, if you want to code an iOS application, the only option that we are left is the software called Xcode. So you need to have Xcode installed within your machine in order to develop an iOS application. Okay, so Xcode comes with the IDE that you need to develop, as well as a simulator that you can test on. And one thing you should know, that iOS by default has a lot of restrictions, which is good. So given those restrictions, compared to Android, iOS claim that they have a lot of privacy, there are a lot of security, and it is true. Most of the time, it's really hard to bypass an iOS application rather than an Android application. So the restrict mode is really tight on iOS. And only option is if you want to develop an iOS application, you need to own a Mac or Mac OS based hardware, something. It can be a MacBook Pro, Apple Air, MacBook Air, or what do you call those, iMacs or desktop ones, something Mac OS on it, you need to have it. All right. The next thing I would like to talk is these frameworks like hybrid application development. Okay. So over the time, most of the application when you are developing, you are not going to be focusing on one specific vendor or one specific operating system. So you want to develop, you want to gather much crowd as much possible. Okay, so if you are developing an app, so it should run in at least the major two platform, iOS and Android. Okay, so as I mentioned earlier, if you want to capture these two markets, you need to build an Android application as well as an Android iOS application. Okay, these two are two different ecosystems. You need to develop one for Android, one for iOS. But since most of the applications like 9% of time, what we are developing is similar functionalities, similar things are there. So there are hybrid development frameworks which is out there. If you had to write a code once and it will be shipped to two of the major platforms. So you need to write one single code base, and that code base will run as Android application as well as an iOS application. Okay, that's pretty much awesome. So you don't need two developers who developing one for Android, one for iOS. Single developer can develop for the both platforms, and it works. But it is not a silver bullet. Okay, why can't we go and develop everything in one of these frameworks or libraries like Flutter or React Native or Ionic? Why can't we do that? So the main reason that we don't do every single application in one of these hybrid frameworks is that everything has some sort of performance or memory or at least development sacrifice that we need to do. Okay, so if you develop a Flutter application, Flutter runs on what you call engine. Okay, that engine should run on both iOS and Android. That's how they power both platforms. Okay, if you are using React Native, there is something called bridge. Okay, you need to run a bridge in order to make that work. So it's an extra burden on the application itself, the Flutter and React Native, or Ionic, whatever the framework. To give the extra functionality, there are some memory, performance, and size sacrifices that we need to do. So if you are developing a Flutter application, and this Flutter application run on Android, and and compare the same application if you with the native performance, most of the time the native one is taking less memory and have huge performance increments, and most of the time from the bundle size, when you are shipping the application, the bundle size is less. Okay, most of the time. I mean, native in terms of performance, memory, and bundle size, they win, of course, because we don't have to have extra burden on the Flutter engine and Flutter engine or React Native bridge or something. There are no such a thing. Plain old Kotlin and compiled into APK, and it works. But the plus side is Flutter and React Native. They have this option of running this application with a performance and a memory cost, but they work on the both platform as expected. So you don't need to have two developers. You don't need to maintain two code bases. You don't need to have the same logic implemented in two places. Okay, everything will be in one single code base. And for the most use cases, most applications that we see today, these hybrid application development make more sense. Okay, so you will ask, okay, if native is good and Flutter or hybrid development is good, how do we choose? Okay, how do we know this project should be conducted in native? This project we need to conduct in React or React Native. So as a rule of thumb that I have seen, it's not like industrial standard or something like that. From my experience, what I have seen is if you are developing something, which need efficient code execution, of course, I would go with the native approach. Okay, so something like game or something like a machine learning, AI, this kind of thing, I would definitely go with native development. But if you are planning to have a very small application like a shopping cart, which is very fancy, and we are only doing some server side calls and validations and logging a user, that kind of basic stuff, okay, which has some value to it, but the performance, we are not expecting 60 frameworks refresh rate, or we don't expect clear. I mean, we can achieve clear, crystal clear. What do you call the graphics and all? But if you're willing to share some of your performance with the gain that you will take from writing once and executing everywhere, so I would go with Flutter. So as a rule of thumb, if it is needing good performance memory and it should be fast as much as possible, then I would go with native. Even with native, there are two different ways that you can do. So especially I'm talking about Android in here. So what we are doing with Android Studio, we use something called Android SDK, Android's standard development kit. Okay, that's for someone who is developing application like programming language like Java or Kotlin. Okay, but there is another level which we call NDK, Native Development Kit, which is a level beyond, or level beyond SDK. So you can directly call C. Most of you guys know, even whatever the languages are there, Swift, Kotlin, or whatever there's there, C is kind of behind all of everything, especially when it is come to kernel and all sort of level. So you can use NDK if you want really control on your application. I'm talking about ML model trainings or executing a really computational task, which is a single bit is your concern. Then NDK is the place where you want to start. But if you are into native application development, you don't need really budget application. I would go with Android SDK based development. And the other part is, if you can leverage more memory, or you don't mind about the small delay in startup time, I would probably go with something like Flutter or React Native. Okay, those are like sacrifices or trade-off within every platform. You have to choose based on your experience, based on the budget, based on the customer requirement. You have to choose what you're going to do. So most of the time, from my experience, some customers, they come and say, okay, we need this application in Flutter. Okay, they have done their research, they have done the estimation. Okay, they know if you develop this application in Flutter, we have a single code base and we can develop for the two platforms, and it will the development time will be a little bit less than what we have trying to develop in two applications. While maintaining, you don't have to maintain two different applications. We can just develop one single application and maintain that on. So that's kind of flexibility is there with some customers, but some others will say, okay, no, we have tried these hybrid frameworks, they don't meet our needs. We will be only focusing on native application. I don't mind the cost. I don't mind I can bear the cost as long as you can deliver it as soon as possible. I'm good. So that's kind of requirement comes from the customer, and if you have to honor this, of course, if they have made their mind, okay, we're going to be developing in Flutter, we don't have any option other than developing Flutter. The customers can overrule anything, but make sure if they don't know, they have done the research on React Native, and by looking at the requirement, you guys will see it's more into graphical and more animation is needed within that hybrid application development. So I would not recommend, if something fancy is going on, I would go with Flutter, because Flutter has a really nice rendering engine. So it renders very smoothly compared to React Native. React Native is good if you're like, I mean, it has a good rendering engine, but not super fancy like Flutter. So you should know which framework is good for which project. Okay. Make sure you learn at least a little bit on these few hybrid applications as well as these native applications. So we'll be focusing our course into Android and Flutter. Okay, I'll do some iOS and React Native, but not in deep as what we are doing as Android and Flutter. That's because I can't cover everything, but I'll be delivering the course content in a way that, okay, all seems to be the same kind of feeling is there. Excuse me, guys, for a minute. Okay. So next thing I would like to see, like to know, I think most of you guys have followed some sort of programming language, but the main thing that you need to remember, you need to learn at least Kotlin. I have shared a basic Kotlin programming language course, which I recommend highly to the others as well. So please make sure you are following these things. Otherwise, what will happen is it will fail. It will fail you to complete this course. Okay, so try to get basic Kotlin by next week. It's a 2 or 4 hour course. You can get the basics and all. While you are coding in Android, you can learn everything else. One thing is that you need to do. Beforehand that, I saw a lot of you guys are really into PHP and Java C, so that is good. So since you know the basic syntax, that's going to really help you guys throughout the journey. And yes, it will help you guys to learn a lot of similarities in these things. And for the first time, I will be going with Android application with Kotlin, but I will show you guys the old structure and the new way of developing applications. So I will be developing a new, the latest version of Android application development, which is called Android Compose. Okay, so we'll be using Compose to develop applications. If you are familiar with Flutter or Swift UI kind of concepts, those gonna be the same thing. Okay, it's really simple, and we'll be seeing how we can develop a Kotlin Compose application. Okay, we'll see the old way because not Kotlin Compose is like there for around few years now. But most of the project, if you are joining for a application developer, not a fresh project, but something to maintain or something like that, you will see all project applications, which is fine, which is happens everywhere. But we will be learning Kotlin, Android Compose. So it will be really helpful when you are going to the industry. I mean, you have a couple of more years to go with. By that time, Compose will be kicking off. Actually, it's already kicked off, but I will be teaching you the latest and greatest, so you don't miss out on the latest things in the industry. Okay, so a few things that you need to know. One more thing I have forgotten, which is something. You guys know Android native development, iOS development, and hybrid development. But very recently, there is a new kid on the block, which is called native-like application development. So what do you mean by that? So the main reason that Android and iOS, we have to develop two different applications is these are two completely different systems. Okay, but if you take an application, what Flutter and React Native are trying to resolve is have the common code base. Okay, so what do you mean by common code base? So let's assume that we are building a calculator. Okay, so we are building a calculator. So UI, of course, Android have a different UI system. iOS have a different UI system. You should know how to you should know how to build a UI in Android and from iOS. But the logic behind the calculator, how do you do summation? How do you do the mathematical equation? Those business logic, what we call this, whatever the logic behind it, it's going to be the same. It's going to be the same, because otherwise the calculator will give some result on Android, but in iOS it will give a different result. So that is not the case. Whatever the logic that we are expecting to execute, it's going to be both in the same. So the new way of developing is the Flutter. What we'll do is it will create the code as it is. Okay, so UI is developed in Flutter, inside Flutter. The code, the logic behind this, it's going to be in Flutter as well. Then what we'll do is we are stuck with the native, not the native language, but something like outsider for this native environments. So people at Kotlin, they come up with a kind of a solution kind of way. We called it as KMM. Okay, Kotlin multi-platform, multi-module. Yes. Kotlin multi-module, what it does is it's gonna be native applications. Okay, it's gonna generate an Android application which is in native. It's gonna generate an iOS application which is also in native. But the catch is, whenever we want to share some code, it will be totally in Kotlin. That means the business logic, whatever you are trying to do, the common task, but what these two applications going to be sharing, that will be in Kotlin. That means only once you have to write, but it will be converted or deported into iOS and Android. So you don't have to repeat the same logic for two different platforms. But if you write in Android, of course, you can use it in iOS as well, since Android is by default using Kotlin. Whatever you write in Kotlin, you can share it with iOS as well. So that is something new. We call that Kotlin multi-module, KMM for short. So we'll be looking at KMM as well. So the advantage of KMM is you will be developing two native applications. You won't be developing hybrid applications like Flutter or React Native. You will be developing two native applications, but the code, the logics behind it can be shared among the two different platforms. So that's something to look into as well. It is somewhat standing behind the hybrid application development and native application development. Okay, so it's code sharing between Android and iOS, but the UI, whatever you like, you can code it. So we will be looking into KMM as well within this course, and we will be looking into Android and iOS. We will touch upon all these frameworks as much as possible, but we will not be going into much deeper level of understanding based on the complexity of the course and the hours that we have. We'll be looking into high level of all of these application development platforms, and we will develop at least few applications. Okay, and we'll try to code the same application in different forms, and you guys know, okay, these are the basics, these are the things that we need to know, and these are the pitfalls each and every platforms have, and you get a basic overall idea on each and every one. What we won't be covering is advanced topics like structuring enterprise grade application. Like there are design patterns all over the Android ecosystems and iOS ecosystems. We won't be covering those things. It's something for later on. We'll try to get a basic idea, and on the next course or next semester we'll get more into the advanced stuff. Okay, so one question came out in the chat. It is in Flutter we have something called device preview library. So it's if you run both on iOS and Android. Yes, so what happens is, as I mentioned earlier, so Flutter is what we call a preview of your application. If you're running on Windows or Linux machine, it's going to preview how it looks on an Android device. Okay, but it does not guarantee, or it's not saying, okay, this will be the same thing in iOS. Okay, there are some situations that I have come across. It's work perfectly on your Android simulator. The Flutter application is running, nothing to worry about. But as soon as you put it into a Macintosh and you try to run the iOS application, sometimes it crashes. The main reason is behind some customization that we are doing. It will affect the code and it will not work. So yes, when we are developing a hybrid application, we can get an idea. Okay, if this looks something similar in Android, this is going to be the same thing in iOS as well, but there is no guarantee in saying it will work. Okay, it will be look alike, but we have to make sure to run it in actual iPhone or run it in a simulator and see whether it is working. Okay, device preview, yes, the preview is going to be the same, but it's not the 100% accurate way of assuming that it will be working on iOS. Believe me, I have played a few times saying, okay, this will work on iOS as it is. Sometimes it does not work as like that. Okay, so any questions up until these guys? So you know the basic setup, you know the frameworks, you know the cleave cats on each and every one, like how Flutter application is work, how native application works. What are the pros and cons? Any questions up until this? Anyone? Okay. All right. So we will be looking at Android and an Android application with Kotlin. Yeah, so that's about the slides, and we'll see the basic setup for setting up an Android application, and we will try to run it for our first time, and we'll see how it goes. Okay, what I'll do is I will exit this presentation, and I will load the Android Studio in my machine. So make sure when you are working with Android Studio, make sure you have the latest version. Currently, I'm not, but oh, it's electric key, and I have Dolphin, something like that. Yeah, even I'm not at the latest, but you have your night data. Try to utilize this and get into the latest version as much as possible. Okay, so I have installed Android Studio and everything. So you just have to open it, and since I have few applications going on here, I'm not gonna be looking. I'm not gonna be taking a lot of time to setting up. So what I will do is basically once Android Studio. Okay, you guys can see Android Studio, right, or not? Hello.
No, sir. Still see the slides.
Okay, sorry about that. Share my screen. Android Studio. Okay. Hope you guys can see screen with Android Studio.
Yes, sir.
Okay, nice. So I think if you run into any programming language, or if you try to start with Android Studio, you probably have seen this screen. So what I will do is I will create a new project. Okay. And yes, so there are a lot of activities, a lot of things that we can choose from. So we have phone and tablet, Wear OS, Android TV, automotive, and all those kind of application development for Android. So Android initially started as a smartphone operating system, but they have expanded to Wear OS. That means your watch. Now you can develop Android application for your watch, your TV, or your car, or your automotive, whatever it is. But we are not going to be focusing on these few variants, because these are like really niche cases. Like you don't see everywhere. Compared to phones and tablet, it's really hard. Really less amount of people are using Wear OS, automotives, and Android TV. So we'll be focusing on phones and tablet at this moment. And there are few templates that we can start with. Okay, so you can see that there are a lot of ways that you can start an application. There is fragment plus view model. I'm at the bottom actually. So there is the thing called basic activity, bottom navigation activity, empty compose activity, empty compose activity with material 3. So one thing that you guys will notice that Android is really the most of the Android applications, the UI elements, the UI style system that they enforce us to use is something called material design. Okay, most of the applications that you see, they follow the material design guidelines. So if you don't know, if you are a designer, if you like to learn about design systems, please go and have a look around material design system. Where the latest version of material design, they have several versions of it as well. So as of now, the latest version is at material version 3. I mean, it's a design system which evolved up to version 3. You can use the material 3 based applications. Okay, it's in preview because these are like really new, but you can use these things if you like. And you can see that there are 2 ways: basic activity and compose activity. Okay, we will create basic activity as well as an empty compose activity. Just to give you an idea, what is the difference between these 2 versions. Okay, and there is empty activity. We will be a lot of talking about activity and everything. There is full screen activity, like something which has run on full screen, add mob activity, Google Map, pay, play, login activity, a lot of templates that we can start with. But for our easiness, what we'll do is we will you guys can try it out. Even there is something called fragment plus view model. This is something I would consider a little bit advanced, but since you are starting, I would go with basic activity. Okay, and later on we will see how the compose activity will looks like, how these two are different approach or different ways that we can start developing Android applications. So I'll go with I haven't tried Android material basic activity material 3, so I'm gonna give it a try and see what's there. So I'll select this one and make sure as you can see when you're trying, this is in still preview mode. That means it is not like the full version. It's not. It can break things. It will change things. You might experience bumpy things in here. So be prepared for changes. I would not recommend to reuse preview components in a production application. I would just go with something stable, like with the material stable version. But since we can explore things in material 3, I would go with basic activity with material 3. Okay, next screen. This is something very important, naming your application. So I would like to keep applications names for your course, so I don't mix with other courses as well while I'm doing. So this is your course code, if I'm not mistaken, and I would go with the year as well. So this should not be something like this. It should be something really meaningful. If you are developing an application, go with a real world application name. If you are developing a food application, just give it a food application or something really catchy, so it will be shown in your app launcher when you deploy it in your application. Okay, so for now I'm giving dummy name. It will not make sense for anyone else, but if you are developing a real world application, give a meaningful name. And the next thing that you need to know is this package name. This is very important. The reason behind is that this package name should be unique. Otherwise, what will happen when you're trying to deploy this application in Play Store or somewhere like that, they won't allow it to deploy there. The main reason is this. This is something unique for each developer or each company. So the basic guideline behind the naming these things is reverse. Have a reverse domain name. So if my domain were to have hrandika.com, okay, I would say com.hrandika, and you guys can't see my screen? I'm not sure. Is that what you're saying? Let me share the screen again. Oh, I think How about now? Do you guys see this both screen? I think when I'm sharing. Can you see now the? Okay, sorry. So let me go back if you haven't seen this as well. So we have the selection of basic activity or compose activity. I would go with basic activity with material 3 design. And I have named my applications like this. And the package name in here, it's called com.hrandika. This is the reverse domain. So make sure when you are developing application, this to be captured at initialization of your project. Otherwise, in the middle of the project, changing this, it's a little bit tricky and a little bit hectic. So make sure get the correct package name, reverse domain name in your application, and followed by a unique signature. So I would say, since I am developing Android application, I would have the signature as Android as well. Make sure this is something unique. If you're going with, if you're trying to have this uploaded in internet or in a Play Store. So make sure that is unique. And where these projects going to be saved, I will be having my default location. And as of now, I think I can't even change the language. It is fixed with Kotlin for the material 3 design, at least I think. So we have to use that. And this is something that you guys need to know. This is the minimum SDK version. Okay, minimum SDK version in sense we were talking about the version and API level. Okay, so we'll be looking at this. So okay, so Android have 2 different way of communicating its capabilities as versions, as API levels. So for instance, Android 4.1, which we call a name for everyone else to have a catchy name, we called it Jelly Beans. Okay, so Android version 4.1 is also called Jelly Bean. Okay, and it has the API version of 16. Let me come into the next phase and I will explain why it is called API level 16. And you also have Android 4.2, which is also Jelly Bean, and the API level is 17. Okay, somewhat in occasions, I'm not sure whether I have it. Yeah, in here you won't find a lot of things that is changing by the name. If you look at, okay, this is perfect example. So for the greater public, it will be Android Jelly Beans 4.1, and 4.2 it's still called Jelly Beans, and the API level is 17, and still Android version is 4.3, it's still called Jelly Beans. So these all things are, we can consider as Android Jelly Beans. So the version is still in Android 4, but the minor versions have been increased by 1, but the code name, the name given is still Jelly Beans. But the API level, these capabilities 17, 16, 17, 18, those are like the capabilities which are added to the Android ecosystem, or sometimes some deprecated features. For example, let's assume that in Android 16 to 17, there is a new feature that was introduced, and it is not like a major feature that we need to consider about. For some, they have been introduced some security releases. They may be introducing some API features like accessing a camera or new fingerprint reader, this kind of things, which are really related to development tasks. We will be having these kind of releases, and The people who are developing Android application, they are really keen on these API level changes. So if you are an Android developer, the main focus of your development is not to this version, at least this API level. Okay. So if I am a developer, I'm curious about the API level, because that indicates what are the features are there, what are the things are not available. So from 16 to 17, there will be features that, which is not available in 16, but available on 17. Let me give a simple example. Let's say we have come up with a new way of reading fingerprints. Okay, there's a new hardware addition. Earlier there was no fingerprint readers in our phones, but later on the hardware added, and there was a change. We need, as a developer, we need a way to interact with the hardware which is attached to it. We need to read the fingerprint reader, or we need to get some data in from that. So that kind of a new feature is added to our hardware. But to fully understand its software, or to interact with its software, API level 16 has no idea, has no way of communicating with that device. They don't have the drivers and everything on. The Android 17, okay, API level 17, they have introduced new set of APIs, or new set of classes, or new set of methods that which we can communicate with the fingerprint API. I'm not talking about a real world situation, but I'm in a hypothetical way, I'm saying the API level will introduce new features when we go by. Okay, so if you want to develop an Android application, we must go for the lowest level as much as possible, because these API levels have the majority of people in the world. If you look at this, if I select API version 16, your app will run on approximately 100% of all the devices. So based on the devices and the devices count out there, if I choose API 16, any phone in the market theoretically should be able to run our application. But if I go higher, like I would say, no, I have some features introduced in API level 15, which is iris scanner, okay, which is not available in API 24. API level 24 did not have such a feature that we can interact with the iris scanner, but 25 has. If I select 25, now you can see our application running, the availability of our application is reduced to 92%. That's because the higher the API levels that we go, the less amount of people who will be using these things. Okay, if you go with API level 32, only 5% of the Android ecosystem devices are there. Okay, so unless you have a special requirement or a special API level that was introduced by this Android Studio or the hardware manufacturer, whatever it is, make sure to go with the latest, so the least version, the least API version. And if some restrictions come, if you find, okay, you are adding a library and the library will complain, okay, we can't work with this API level, you need to increase this now. So in that case, try to increase. As of now, we don't have any issues. Just go with the latest, least API level, so you have more device coverage in your application. Okay. All right. So we have this, and we are also remember API levels. Sometimes they deprecate things. Deprecate in the sense they no longer support. There are some features which will be taken out of the ecosystem as well. So it's because of they are no longer valid, or they no longer support, or they have we have ended the support for the project or library. So deprecation also happens. So make sure not only adding but removing can happen within these parts. So if you look at Android source code itself, they will say, okay, this feature will be deprecated on Android 18. So you have to find alternative or something like that. That happens. So make sure you know that as well. Okay, application name. They are complaining something around that. All right. I think that's about it. Yeah. Okay, let's go to finish. So it depending on your internet speed, depending on how much you have developed, it will take a little bit of time you to get the first project up and running. So right now there are few libraries that is download within my machine. So depending on your status, it will change, but eventually it will be available. But concurrent changes or concurrent application development will be much faster. So this is gonna be the application that we're gonna be developing. This is the Android Studio most of the time that we will be working with. Okay, so this is the code environment, the IDE that we will be using throughout our course. So it is downloading a bunch of dependencies, the libraries that we need to run application. Of course, not a single application I have seen which is only utilizing what is available on Android itself. So Android itself provides some things that we can do, but they are not enough. So for example, let's say you want to do a REST API call, then of course we can do it all way, like I mean, not all way, in a way that is we are using all the barebone Android support, or we can use a simple library. It will increase our bundle size, but it will make life easier. Okay, so make sure these dependencies are downloaded. So to run even our basic application, it will depend on other libraries. So we are downloading those things as we speak. And one thing I would like to know, how many of you guys know about build systems? Anyone knows what is a build system? What's its purpose and all? Anyone knows? Nobody? Okay. So one of the assignments or one of the tasks at the end of the day is you guys to look at different build systems available in Java programming language or Android. So I will give what is the default build tool available in Android development. We call it Gradle. Okay, Gradle act as a build tool which will compile all our this source code into a runnable on a device. This is just code. We have to compile it. We have to make sure it is in all the dependencies are there, and everything that we need to run this as a single application is going to be handled. It's going to be compact into one. We built it, and we will be deploying it into our Play Store or a mobile device or a simulator. So all the heavy work of building these applications, shipping, installing these applications is actually installing is done by Android Studio itself, but at least building and dependency management is done by Gradle. So there are other build tools available in Android or Java ecosystem. So you guys have to go and do a research on what are those and what are the difference between Gradle and other build systems. Okay, so if you have developed a Java-based web application, of course, you might probably have seen the other build, one of the most popular build systems. I'm not going to say the name, but you guys have to see for yourself and try to come up with what are the things that you will see, what is the difference between these two build systems. Okay, what basically a build system does, that is something also important as well. Okay, while this happens, one quick thing that I would like to go is this device manager. Okay, so I have created virtual devices. If you're planning to run this application on a virtual device, make sure you have created the virtual device. It's really simple. On the right hand corner, you will see the device manager, and you can select create device, and you can select the phone, whatever the operating system, what is the phone dimension and everything. You just go hit next and select the operating system, which will be running Android. I'm going to be running Android 33. If you have something new, you can also download and work with it. I already have downloaded this, so I'm going to be using this version. If you plan to go with something less, you can always download and work with it. And I'm going to hit next, and I can give whatever the name I like. But one thing that I would like to do is show advanced settings, and I would go with the call boot. That means every time when I am running the simulator, it will boot emulator. It will be booting up from the start. Quick boot will show the emulator very fast, but a lot of time it gives trouble. So I would recommend to go with the cold boot and just click finish. It will create a new virtual device like this. Okay, and there are emulators which are currently running right now. I don't have any emulator running on. This is device manager. It's list out all the physical and virtual devices. Okay, and the emulator, whichever the emulator that we are running, it will show in here. And we will look into device files explorer once we run this application. Okay, all right. So our application is almost ready to launch. Okay, so we have a couple of files in here. First fragment, first activity, second fragment. We will look into these. These are the tests. These are the REST file. What are these? These are the Gradle script. And one thing that you guys need to remember, there are different ways that you can look at this project. Okay, the default view is Android, as you can see in here, and most of the time this is okay if you are developing an Android application, but sometimes you need to have a different perspective of this application. I would go with project perspective, which is more or less we are used to do. But if you are developing only source code, I would go with Android view. The project view gives more idea, more of a feelings. We will look into each and every one later on. Just have this change and see what's going on in here. Project and files, test related, and production. So most of the time we'll be switching between Android and so you guys can see my screen, right?
Yes, sir.
Okay. So we have these different perspective of our application. I would just simply stick with Android for now. And to start with, since this is automatically generated, we can build or make the project from here, or I can simply run by selecting an emulator in here. So I have two emulators, which is like the same thing. I would go with this, and I would hit this run app button, and it will automatically pop up the emulator in here. So you can see the Gradle build is running. That means it is building the application as of now. It just prepared the application as we spoke earlier. But right now what it's doing is it is building the application. It is trying to connect to an emulator. Since my emulator is shut down, it will open up a emulator. Once the emulator is done, what it will do is it will install the application that we have currently created. Okay, waiting all target device to come, and it is now installing the application that we have developed. At least now it is launching. Okay, so it shows this. It shows this first fragment, and that's it. It's the first thing that you can see. It's at the next button. It's just the second fragment, and if you go previous, it's got the first fragment. This is kind of a basic application. If you have your device running around, if you have a physical device, just plug it in and enable the developer mode, and you can select the device from here. Okay, even you have pair over Wi-Fi. If you have a Wi-Fi connection, which you have, what do you call the device with you? I mean, the device and the machine are in the same Wi-Fi network. What you can do is you can pair these, pair your iPhone, pair your Android and your machine without a wired connection, and you can use it, and it will automatically deploy the application wirelessly. So you don't have to plug in the wire and everything. You can simply run this application over Wi-Fi. Okay, so there you go. So without doing much of effort, this is our first application that we have run. So there is this nice button over here where you can click and says replace with your action, and our first application works. So my initial goal is, if you haven't get up to this point, please do so and run your first application. And we did not do anything, kind of, because it's the default application that we will see, but at least we have some starting point for our application. We have something to be proud of. We know how to install this in our device and see what's going on. So yeah, so that's about it for running our first application. And our first, we will talk about the fragments and everything. Just don't worry about it as of now. Just know it is there, and you guys have the option of running this. Okay. Okay. Any questions up until this, guys? Anything that you guys need to know? I know it's the UI might be not familiar to you guys, but eventually when we are developing, when we are building, you will get used to all these gagematics and everything that around here. We will be looking at each and every section on the here. Right now, most important thing is this emulator, device manager, and this tiny play button. Yeah, anything else, guys? We'll be looking into the old project structure, and we'll be looking into the new compose based project structure as well. So anything that you guys need to know about this setup? Anything that is okay? So silence means no. All right, let me stop sharing my screen and let me stop recording.